Hi friends, welcome to our channel ecabeyaantrix. In this video, we are going to learn about two new diodes, PIN diode and Varactor diode in detail with applications and diagrams and several comparison also. Okay, we are going to compare PN junction diode with PIN diode and Varactor diode and so on. Okay, so this video is going to be a very important video for semester exam students and competitive exam students like TRB exams and TNPSC exams and so on. Okay, so this video will be highly useful. Kindly watch this video till the end for better understanding. In the previous video also we have learnt about PN junction diode in detail and Senor diode and Schottky diode also. Okay, so have a look on the previous videos also. It will be in the playlist called ECE lectures playlist in our channel. Okay, so come let's start the video. If you haven't subscribed to our channel, do click the subscribe button and click the bell icon for further updates. Come let's start the video. Okay, first we are going to learn about PIN diode. Okay, and in the further slides we are going to learn about Varactor diode also. Okay, so PIN diode. What I mean by PIN means, so it's the symbol is similar to a PN junction diode, but there is a slight difference in the structure. Okay, so P stands for P-type semiconductor and N stands for N-type semiconductor, and the center middle I letter stands for intrinsic type semiconductor. Okay, what is intrinsic means? Pure semiconductor. Okay, pure means there will be no doping or no impurities in it. Okay, so this type of combination results in a PIN diode. Okay, P stands for P type, I for intrinsic and N for N type. As we learned earlier, P type means there the majority charge carriers will be holes, right? And in N type means the majority charge carriers will be electrons, and in intrinsic there will be equal number of electrons and holes, as we learned earlier, right? There will be no doping or no dopant added or no impurities added, right? So this is a pure type of semiconductor. It depends only on the that is the conductivity depends only on the temperature, right? You remember, right? Okay, so this is the structure of the PIN diode. Okay, so P type on one side, N type on the other side, and the third layer is introduced called intrinsic or undoped semiconductor in the center. Okay, it's a sandwich between P type and N type, right? Okay, and also the depletion layer will be in between the intrinsic semiconductor. Okay, so due to the biasing conditions, the intrinsic the depletion region width increases or decreases based on the voltage applied, either forward bias or reverse bias. Coming to symbol, the PIN diode symbol is similar to a PN junction diode actually. Okay, so the same symbol only, but in some textbooks they'll be referring in it a small arrow or some different indications, but generally the PIN diode symbol is commonly notated as the same symbol as a PN junction diode. Keep that point in mind. And coming to terminals, there will be two terminals as usual: anode positive terminal, cathode negative terminal. Okay. And coming to operation, okay, so there are three modes actually. Okay, so open circuit operation, forward bias and reverse bias. Okay, so in open circuit the depletion layer will be very thin in P and N regions. Actually, in some textbooks there will be a notation called P plus and N plus here, because the symbol plus means there will be high amount of doping than usual. Okay, so P plus means there will be extreme level of doping in P type and N type. If the doping is increased, we have learned earlier, right? If the doping is increased, automatically the depletion layer will be very thin, right? So in the P and N regions, as the doping is very high, the depletion layer will be very thin in P and N regions. But in the intrinsic layer, so there will be no doping in the intrinsic layer, right? And hence the depletion layer will be very thick in the intrinsic layer region. So keep this logic in mind always. Okay, and there are three conditions as I said earlier, right? So in zero bias, that is we haven't applied any external voltage to the PIN diode, right? At zero bias, the intrinsic layer has high resistance, which means that the high resistance usually means that the conductivity will be very low, right? The I layer has high resistance, so the charge carriers won't be moving from P type to N type and vice versa, right? So there will be no conduction or no current flow in this case, that is in the zero bias case, right? When the forward bias is applied, this is the second case of operation, right? When forward bias is applied, that is the P type is connected to positive terminal of the battery and N type is connected to negative terminal of the battery. Same operation as in PN junction diode, same connection, right? But in that case, the carriers will be start flowing from P type and N type regions into the intrinsic layer simultaneously, right? So carriers are injected into I layer, okay, from P and N regions. Coming to P type region, there will be holes injected into the I layer, and in N type region, the electrons are injected into the I layer from the N region, right? And as a result, the charges flow across the I layer, right? And as a result, the I layer's resistance starts decreasing, which means the conductivity starts increasing gradually, right? In forward bias operation. Okay, so the same same diagram, same VA characteristic as in PN junction diode, okay, forward bias, same forward bias operation as in PN junction diode, right? And when reverse bias is applied, as I said earlier, eventually the depletion layer width will be increased, right? When reverse bias is applied, the P type is connected to negative terminal of the battery and N type is connected to positive terminal of the battery, right? The depletion layer width will be increased, and at a particular voltage, okay, at a particular reverse voltage, the entire I layer will be occupied by the depletion layer, right? The entire I layer means the entire intrinsic layer will be occupied by the depletion layer. Actually, the depletion layer will be inside the I layer. Right, as the reverse voltage is increasing, the I layer is completely occupied by the depletion layer. Okay, that particular voltage is called as swept out voltage. So, at a particular stage, the entire I layer will be covered by the depletion layer. Okay, so we couldn't differentiate both the layers, right? So, that particular voltage in which the entire I layer is occupied by the depletion layer is called as swept out voltage. Okay, and in reverse bias condition, it offers high resistance. Okay, that's the main case, right? So in reverse bias, the depletion layer width will be increased, right? And as a result, the entire I layer will be occupied by the depletion layer, right? So in that case, it offers high resistance, which means that the current flow will be very low. Okay, that is comparing to forward bias operation, the reverse bias operation offers very low current only because it offers very high resistance in this condition, right? So this is the three cases of operation in a PIN diode, right? And coming to applications. So PIN diode is widely used in these applications like RF switching, okay, radio frequency switching, radio frequency attenuation, okay, the signal mixing, matching, and so on. And in microwave communication also, and in photo detectors, radar systems, optical fiber communication, and so on. So generally, coming to PIN diode, you have to remember one key application, that is RF switching. That is very important. Okay, while thinking of a PN junction diode, eventually the rectification comes into mind, right? And coming to Zener diode, regulator, right? Voltage regulation comes into mind. Coming to Schottky diode, fast switching comes into mind, right? Coming to PIN diode, RF switching has to come in mind, right? So keep that point in mind. RF switching is a key application of PIN diode. Okay, got the point? And I have to compare both the PN junction diode and the PIN diode. Okay, so for better understanding. Okay, coming to PN junction diode, as I said earlier, there will be two layers, right? Okay, P region and N region. And coming to PIN diode, there will be three layers, right? Three layers, P region, and the center region is called intrinsic or I region, and N region, right? So two layers in PN junction diode, three layers in PIN diode. And coming to PN junction diode, there will be no intrinsic layer, right? And in PIN diode, that's the extra layer, right? And depletion layer, coming to PN junction diode, that will be moderate actually, narrow PN junction diode. Coming to PIN diode, that will be very wide. Okay, so hope you understood that logic of wide depletion region, right? Okay, so since the in reverse bias operation, the depletion layer starts increasing, right? Okay, so the PIN diode is widely used for reverse bias operation only. Okay, comparing to forward bias operation, because PN junction diode already does that same operation only, right? And coming to junction capacitance, in PN junction diode it will be higher, and in PIN diode it will be lower. Okay, this point is also very important. PIN diode offers lower junction capacitance. Okay, because that is the width of the depletion layer will be high, right? So C, what is the formula for C actually? C equal to epsilon naught A by D. Okay, so you remember that formula? C equal to, we have learnt in our 10th and 12th classes, right? Epsilon naught A by D. So if the depletion layer width is increased, obviously the junction capacitance will be lowered, right? So that's the key point here, right? Mainly PIN diode is used in reverse bias operation, right? So this point is included mainly, okay? And coming to operating frequency, in PN junction diode, low to moderate frequency operation only. But in PIN diode, RF, as I said earlier, RF switching, microwave switching applications, attenuators, right? Very high frequency applications. Okay, and the main function of PN junction diode is rectification, and in PIN diode, the main function is RF switching, attenuation, and photo deduction, right? And coming to switching speed, PN junction diode offers a moderate switching only, right? PN junction diode நாலே உங்களுக்கு ஞாபகம் வர வேண்டியது rectification தான், right? AC to DC ஆ மாத்துறதா main purpose. Okay, half wave rectifier, full wave rectifier, bridge rectifier, that will be dealing in the further videos, right? In PIN diode, switching speed will be very faster at high frequencies, but not as faster as a Schottky diode. Okay, so among all the diodes, Schottky diode only offers high switching speed. Keep that point in mind. But comparing to PN junction diode, PIN diode offers a higher switching speed, right? Okay, at high frequencies mainly. Okay, and this is all about PIN diode and its comparison, right? And the second diode we are going to learn about in today's lecture is Varactor diode, right? So as the name implies, Varactor means variable reactor diode or variable capacitor diode. Reactor stands for capacitor here, okay? And also called as varicap diode because it is widely used in voltage controlled capacitor. Widely used as voltage controlled capacitor. As the voltage varies, it acts as a capacitor. Okay, so that's the main operation for a Varactor diode, right? And it is operated mainly under reverse bias operation, right? So coming to Varactor diode, we have to keep this point in mind. That is variable capacitor, right? This is the symbol, right? So a diode, normal diode symbol plus a capacitor, right? Capacitor can be drawn like this also and this also. This will be a variable, right? So that is variable capacitance is included. So these three are the symbols of Varactor diode. We can use it alternatively, right? And coming to its operation, okay, in a Varactor diode, the PN junction act as a parallel plate capacitor actually, right? And the P region and N region act as the plates, that is the parallel plates, and the center depletion layer, that is the depletion layer act as the dielectric as in a capacitor. So it looks like a capacitor actually, parallel plate capacitor. P and N region as the parallel plates and the center depletion layer as the dielectric in a capacitor, right? And coming to junction capacitance, the junction capacitance is inversely proportional to the depletion layer width. We have learned, right, as I've said in the previous topic, C naught equal to epsilon naught A by D, right? Or C equal to something, right? As the depletion layer width is increased, the junction capacitance is decreased, right? So they are inversely proportional, correct? So that point is mentioned in the second point, right? And both varied by varying the voltage across the diode, that is the junction capacitance and the depletion layer width, that is C and D, both varied by varying the voltage across the diode. Okay, so if the voltage across the diode is varied, then obviously the junction capacitance will also be varied, okay, because V is directly proportional to D actually, because V equal to E into D. Okay, so according to the formula, V equal to E into D. So as D is increased, or as V is increased, D is also increased, right? Okay, and as a result, the capacitance varies, right? So V is proportional to D and C is also proportional. That is inversely proportional to D. Okay, so V is directly proportional to D, which is inversely proportional to C, right? Okay, got this point? Okay, so also we know that C equal to Q by V. So as V is increased, obviously capacitance will be decreased, right? So all keep this formula in mind, right? Okay, and under reverse bias operation, as we know already, the depletion layer width will be increasing, right? And as the depletion layer width will be increasing, the capacitance, junction capacitance obviously decreases, right? So this is the main operation in a Varactor diode. So it is mainly used as a parallel plate capacitor, that is as a voltage controlled capacitor, right? Because the voltage controls this capacitance logic, right? Okay. And coming to applications, mainly it is used as a voltage tuned capacitor. Okay, wherever tuning comes, okay, so wherever tuning comes, you have to keep this Varactor diode in mind. Okay, so tuning means Varactor diode, right? Voltage tuned capacitor or voltage controlled oscillator, it is widely used in these applications. Okay, and also in low noise parametric amplifiers and mixers, and in PLL, that is phase locked loops, we have to lock that particular device in a particular frequency, means we'll be using phase locked loops, right? So there also this Varactor diode is used. And in microwave communication systems, satellite communication systems, for tuning applications, they are used in these systems, right? So these are the main applications. So the key application here is tuning. Keep this point in mind. Rectification, diode, normal PN junction diode, right? And fast switching Schottky diode, and then RF switching PIN diode, and tuning applications Varactor diode. Okay, that's the logic. Okay, so this is the on conclusion, okay, so we are comparing every applications of the diodes learned so far in our lectures, right? Coming to PN junction diode, it's widely used in rectification, that is AC to DC conversion, right? That's the main application. You have to keep that PN junction diode in mind for rectification, right? And coming to Zener diode, voltage regulation, right? Key application. And coming to Schottky diode, high speed switching applications. This is the best choice, right? And coming to PIN diode, we have learned today, right? RF switching and RF attenuation. So while hearing these words, you have to remember PIN diode only. And coming to Varactor diode, variable capacitor diode, tuning applications. That is variable capacitance. It acts as a variable capacitor, right? So these diodes and these are the main applications of these diodes. It's used in wide applications only, but the key application is these, right? Okay, so these applications are very important for competitive exams because I have faced so many questions related to symbols of diodes. Okay, so and also the applications. Okay, so we have to learn these points in mind. Okay, keep these points in mind. Okay, so this is all about Varactor diode. And today in this video, we have learned about two important diodes, PIN diode and Varactor diode. Hope you understood this video. So if there are any doubts, do drop the doubts in the comment section. And I have included an MCQ question also in the comment section. So attend that question also. Okay. This is all about in today's video. We can watch the further topics in the next video. Until then, thank you.